Welcome to Max Mathematics class. In today's class, we are going to look at how we can prove these 5 trigonometric identities. Relax yourself and enjoy the class. Question 1. Now we are going to prove that tan theta minus sin theta over sine cube theta is equals to sec theta over 1 plus cos theta. So with the help of these Pythagorean identities, reciprocal identities, and then quotient identities, we are going to prove this. So let's start with the left hand side. Picking the left hand side, we have tan theta. We will write it based on this reciprocal identity, quotient identity here. So we are going to write cos tan theta as sine theta over cos theta minus sine theta. Now the whole of this to be divided by sine cube theta. So if you solve this fraction here by making this 1 over 1, so the LCM here is cos theta. Now cos theta to go into cos theta will give us 1, and 1 times sin theta will give us sin theta. Then 1 to go into cos theta will give us cos theta, times sin theta will give us sin theta cos theta, times the reciprocal of this, which is 1 over sine cube theta. Because of division here, we can turn this division to multiplication and then write the reciprocal of this. So after this, you will notice that in the numerator of this fraction here, sin theta is common, so we factor it out. So this will be equal to sine theta open bracket 1 minus cos theta all over cos theta times 1 over sine cube theta. So from here, this sine theta go into this sin theta will cancel one of these, so that we now have sine square theta out of sine cube theta. So we are now left with 1 minus cos theta over cos theta times 1 over sine squared theta. And we know again that sine squared theta is equal to 1 minus cos squared theta. Is one of the Pythagorean identity we showed you. So we are now going to replace this with this, so that the new value we now have will be equal to this numerator here. We'll multiply this one to give us 1 minus cos theta all over cos theta times 1 minus cos square theta. So after this, we are going to expand this, because one of the algebraic identities is if you have x squared minus y squared, it will be equal to x minus y times x plus y. So this is the expansion of this, or the factorization of this. Now the same thing is applicable to what we have inside the bracket here. So we are going to expand that denominator there into this formula. So we now have 1 minus cos theta over cos theta times 1 minus cos theta times 1 plus cos theta. So after this, we can now cancel out this, cancel out this. We are now left with 1 over cos theta times 1 plus cos theta. So it is now time for us to expand this. Now this can be expanded as 1 over cos theta times 1 over 1 plus cos theta, so that this will become sec, one of the reciprocal identity. So we now have, 1 over cos theta is the same thing as sec theta. So here now we are going to have sec theta times 1 over 1 plus cos theta. So we can make this 1 over 1 as well. So from there now we can now get this value. So if this sec theta times 1, it will give us sec theta over 1 plus cos theta. So you can see the left hand side here and the right hand side here. Now this value here has been proved. See the final answer here. So proved. This value has been proved. So let's move to number 2. So number 2, we have 2 tan theta minus sine 2 theta over 2 sine square theta is equals to tan theta. So we are going to take the left hand side, which is this one. Now this is one of the things that will help us. 2 sine 2x, sine 2x will be 2 sine x cos x. So take note of this value. We are going to use it to prove this. So it's the major identity here to handle this sine 2 theta. We already know that tan theta is the same thing as sine theta over cos theta. So taking it from that point, we are going to rewrite 2 sine theta over cos theta minus this sine 2 theta. Now we can write it as 2 sine theta cos theta. So all to be divided by 2 sine theta. So after this, we are going to solve this one so that we now have 2 sine theta. If we make this 1 over 1, so minus 2 sine theta cos square theta all over the LCM, which is cos theta. Now cos theta to go into cos theta will give us 1. 1 times this will give us this. Again, I want to go into cos theta will give us cos theta. To multiply what is here, it will give us 2 sine theta cos square theta. So we are now going to convert this one to multiplication. Then we now have 1 over 2 sine square theta. So after this, there is something common in the numerator, and that is 2 sine theta. So we'll bring it out. We have 2 sine theta times 1 minus cos square theta all over cos theta times 1 over 2 sine square theta. This 2 sine theta we'll cancel out one of these so that we now have sine theta here. So the new value we now have will look like this. 1 minus cos theta over cos theta times sine theta will give us sine theta cos theta. Square. So now this value here we have in the numerator, we know that sine square theta is the same thing as 1 minus cos square theta. So we are going to substitute this value into this equation so that the new value we will now have, this will be equal to sine square theta over sine theta cos theta. So let's clean the board. So we can now see that this sine square now, this value here, this sine cancel out one of these. So the new value we have now will be sine theta over cos theta. So, and we know that sine theta over cos theta is equals to tan theta. Therefore, 2 tan theta minus sine 2 theta over 2 sine square theta is equals to tan theta. Proved. So this is the final answer we got here. We have proved it. So let's move to the next one. Now from the number 3, we are going to prove that 1 minus tan square theta over 1 plus tan square theta is equals to cos theta plus sine theta in bracket times cos theta minus sine theta in bracket. So this time around, let's pick the left hand side again. The left hand side. So take note of this. We are going to make use of this Pythagorean's identity here. So if you check this number 2 here, is the same thing with the denominator here. So take note of that. This number 2 here. So we are going to rewrite this numerator here as 1 minus sine square theta over cos square theta. Now to be divided by the reciprocal of this, that is, 1 plus tan square theta is equals to sec square theta. So we are going to divide here by sec square theta. So after that, we are going to solve this fraction here 1 over 1, so that what we now have will become the LCM now is cos square theta. So we now have a cos square theta as the LCM. So if 1 come here, we are going to have cos square theta minus, if this cos square theta come here, we are going to have 1 times. This will give us sine square theta times the reciprocal of this, which is 1 over sec square theta. So after this, we are going to check this. The reciprocal of this again is cos square theta. This value now, the reciprocal of it. So this is the same thing as, know that 1 over sec square theta is the same thing as cos square theta. It's the same thing. So we are going to replace the whole of this with this. So if we do that, we are going to have cos square theta minus sine square theta all over cos square theta times cos theta. So this cos theta now, this cos theta cancel out this. So we are now left with cos square theta minus sine square theta. And we know that if you have x squared minus y squared to be equal to x plus y times x minus y. So difference of two squares. That's what we have here now. So if you apply it to this, we are going to get cos theta so this will be equal to cos theta plus sine theta times cos theta minus sine theta. So you can see we have proved the right hand side. So therefore 1 minus tan square theta over 1 plus tan square theta is equal to cos theta plus sine theta, then cos theta again minus sine theta. Proved again. Now let's move to number 4. Now in our number 4 we have cos raised to power of 3 theta plus sine raised to power of 3 theta over cos theta plus sine theta is equals to 1 minus sine theta cos theta. Now it is this reciprocal that will help us. This reciprocal here is what is going to help us to solve this, because we are going to expand this value this way. When you have x raised to power 3 plus y raised to power 3, this is the expansion, x plus y in bracket times x squared plus y squared minus xy. So we are going to use it to expand this number 1. So this will now be equal to this cos 3 theta. We can write it as cos. Let me even write this reciprocal here so that you can see it. If you have x cube plus y cube, it will be equal to x plus y times x squared plus y squared minus xy. So this is the reciprocal we are going to use to expand this one. So take note of that. So this value now we can write it as cos theta plus sine theta times, we are taking the left hand side, times cos square theta plus sine square theta minus cos theta sine theta in bracket all over cos theta plus sine theta. So automatically you can see that this value cancel out this. So we are now left with cos square theta plus sine square theta minus cos theta sine theta. So, and again we know that this reciprocal here we know that this value here is the same thing as 1. That is, if you have cos squared theta plus sine squared theta is equals to 1. It's one of the Pythagorean identities. So we are going to replace this value now with 1, so that our new value will become 1 minus cos theta sine theta. So you can see we have proved it here. So in conclusion, therefore, cos cube theta plus sine cube theta over cos theta plus sine theta is equals to 1 minus sine theta cos theta. So proved again. Proved again. Proved again. So let's move to the last one. Now we have sec squared theta plus cosec squared theta to be equal to tan theta plus cot theta in bracket square. So this time around, let's take the right hand side here and expand it. The right hand side, but know that we are going to make use of these values here. These are the ones we are going to use. So take note of that. So we are going to take the right hand side now to make it the left hand side. So by expanding this one, we are going to have tan theta plus cot theta will be equal to the expansion here. We have tan theta plus cot theta times tan theta plus again cot theta. So that is the first thing. We can now expand it by saying this times this. Tan theta times tan theta will give us tan squared theta. Tan theta again times cot theta will give us plus tan theta cot theta. Cot theta times tan theta will give us plus tan theta cot theta, and cot theta times cot theta will give us plus cot squared theta. So after this expansion, this is what we have, and we know that these two are like terms. This one and this one, they are like. We have to add them. So we have tan squared theta plus 2 tan theta cot theta plus cot theta square theta. So we also know that tan theta is equals to 1 over cot theta. So they are reciprocal identities. Now we are going to substitute cot theta with we are going to substitute tan theta with this value here, so that the new value will become tan square theta plus 2 tan theta times tan theta, or we can change it as cot theta is the same thing as 1 over tan theta, it's the same, so that we can now write 1 over tan theta plus cot square theta. So from there this tan theta will cancel out this. So what we now have, tan square theta plus cot square theta plus 2. And we know again from one of their identities we showed that tan square theta is the same thing as 1, or rather 1 plus tan square theta is equals to sec square theta. And again 1 plus cot square theta is equals to cosec square theta. So from here now, we can make tan square theta the subject of the formula so that it will now become tan square theta will be equals to sec from here. This will become, if we make tan square theta the subject of the formula, to become tan square theta is equal to sec square theta minus 1. So if we make this one the subject of the formula too, so we are going to have cot square theta to be equal to cosec square theta minus 1. So we are going to substitute these two values here in this place here. So our new values now will look like this. So here now we are going to have sec square theta minus 1 plus cosec square minus 1 plus 2. So if we collect the like terms from this, we are going to have sec square theta plus cosec square theta minus 1 will give us minus 2 plus 2 that is already there. So you can see that these two cancel out this. We are now left with sec square theta plus cosec square theta, proved again. So in conclusion, therefore, sec square theta plus cosec square theta is equal to tan theta plus cot theta in bracket squared, proved again. So thank you for watching. If you have not subscribed to our channel, please subscribe.